Hi everyone, we're going to start today talking a little bit about how we can start to measure some of the parts of our cardiovascular system. So the first thing we're going to talk about today is electrocardiograms, or what you might know better is an EKG or an ECG. So these are recordings of the electrical changes that occur in our myocardium during our cardiac cycle. So this is really closely related to what we're going to see with the conduction system that we talked about yesterday. So this conduction system, our EKGs are going to measure what's happening here. So it's the results from the depolarization and repolarization as those action potentials are moving through our cardiac muscle fibers. So it's really beneficial to electrocardiograms that all of our bodily fluids are easily going to conduct electrical currents. So instead of making this a very difficult test to perform, all we really need to do is put some stickers on certain places on our body, connect some electrical leads to those, and we can read the different electrical systems that are happening within our heart, which is really beneficial. So just a reminder to what's happening with that electrical system. We're moving from our SA node. That electrical signal or action potential is going to be sent to our atria. Those atria are going to contract. That signal is going to be sent to our AV node, which is going to pause the signal for just a little bit so we have enough time for that blood to fill into our ventricles. Then it will be sent down the bundle of His to the Purkinje fibers, which are going to cause our ventricles to contract. So let's take a look at a pretty basic electrocardiogram that we should be familiar with. So the systems that we're going to see here, we can see this is a pretty normal, what we see normally with our EKGs. So we start with a P wave, we go to what we call a QRS complex, and then our T wave. So let's see what that means. So our P wave is going to be in the SA node. It's triggering that action potential, so that start of that electrical system is going to show here with the P wave. And then our atrial fibers, or our atria, are going to depolarize, which is going to show, so ultimately our P wave is showing the depolarization of our atria, so both the left and right atrium. Then we're going to move on to our QRS complex. You can see it's a much more drastic look than our P wave. And this is because it's the ventricle fibers depolarizing. So since there's a greater mass in this tissue, we're going to see a greater electrical change. So again, with this really extensive deviation that we see here. And then when we finish this, we can see that it goes back to this kind of baseline here. So really important to remember, our QRS complex is going to show the depolarization of our ventricles. And then finally, we can see our T wave here, a little bit larger than our P wave. So this is going to be the ventricle muscles repolarizing, so kind of the relaxation period here. And that's the end of our one EKG pattern. So that's one heartbeat that we see. So the T wave is going to show repolarization of our ventricles. So if we are paying attention here, we see that we don't really see the repolarization of our atria. And that's going to be because this QRS complex is covering up that repolarization. So remember, our P wave is the depolarization of our atria. Our QRS complex is going to be the depolarization of our ventricles. And then our T wave is going to show the repolarization of our ventricles. There is quite a few other things on here. I don't want you to worry about those. I just want you to remember the different waves and complexes that we see here. I also do want to recommend that you take a look at this YouTube video that I have linked. It gives a really nice detail of what's happening in reading that EKG. So let's take a look at a few examples here that we can see with different EKGs. So at the top here, I have a normal sinus rhythm. We can see our P wave, our QRS complex, and our nice T wave here. And if we take a look at the bottom here, we have ventricular fibrillation. So our heart is beating really, really quickly and not able to give a correct electrical marking. So if we take a look here, if we look at our big boxes, we can see that these are really short waves. So the heart is beating very quickly, but it's also not sending the correct signal, because if you look here, our QRS complex kind of goes up 1, 2, 3 big boxes here, where this one is really only going up 1. So that's ventricular fibrillation. If we take a look at a difference here, we have ventricular tachycardia, and we can see this is going to shoot quite a few more big boxes higher, but again, a very quick heartbeat that we can see here. So these are two types of arrhythmias that you might see in a hospital that might require someone to use a defibrillator to bring their heart back to normal sinus rhythm. Remember, since we have an electrical system, an electrical shock to our heart can help us bring our heartbeat back to a regular arrhythmia here. And then the last example that I have here is actually a condition called Brugada syndrome. So if we take a look, we can see at the beginning we have some normal sinus rhythms. It goes into an abnormal arrhythmia here, even more abnormal, and then it kind of can go back to normal. So this is a syndrome that has very different arrhythmias that can be dangerous for the person. And again, a defibrillator could be something that could help this person as well. If you have any questions, please let me know, and I'll see you next time.